Kia ora tātou. In this video we'll look at a past exam question from the 2018 exam, and the ones related to Lewis diagrams. So the first Lewis diagram question is this one, where we need to draw the Lewis diagrams for these two molecules and then name the shape. So first of all we need to look at astatine, and we see that it's in group 15 of the periodic table, so we've got AS is in group 15, so that means it's got 5 electrons in its outer shell, and then fluorine has got 7, and we've got 5 of those fluorine atoms in the molecule, so it's going to be 7 times 5. So our total number of electrons is 35 plus 5, so we've got 40 electrons. So then I will draw the astatine, AS, and then all of the fluorine, the 5 fluorine atoms around astatine. So 1, 2, 3, 4, 5. And then doing the covalent bonds and putting in the electrons around the fluorine atoms. And then the last thing we'll need to do is count up all of the number of electrons that we've put into the molecule just by doing this. So each fluorine has got 8 electrons around in its valence shell, including the 2 from the double bond. So we've got 5 fluorine atoms with 8 electrons, so 5 times 8, and that equals 40. So we've got no extra electrons to add. So this is a molecule with 5 regions of negative charge, all of them bonding. So that means that it is a trigonal bipyramidal. And you can look at the last video where we look at all the different shapes that there could be. So for the next one, BRF5, we first of all count up the number of electrons in the molecule. So bromine and fluorine all have 7 electrons in their outer shell. So bromine is 7, fluorine is 7 times 5. So this time we're going to have 42 electrons all up. So we'll put the bromine in the middle because that's the one that we've got 1 of, and then we go fluorine, 2, 3, 4, 5, and then the electrons around the outside. And now we know from our calculation before that we've got 40 electrons already from those 5 fluorine atoms, so that means that we've got 2 electrons left over, and then we just need to put them around the central atom. So this means that we now have 6 regions of negative charge, and 5 of them are bonding, and 1 of them is a lone pair of electrons. So that will be a square pyramid. Square pyramid. So yeah, it could be a challenge to memorize all of the different shapes, but you know, practice, practice, practice. Okay, next question. So Lewis diagram and shape for XEF5 are given below. Elaborate on the shape and polarity. So to answer these questions, there's a couple of differences to what we would have done last year. So we will say the number of, so we're talking about the shape first, so we'd say the number of regions of negative charge. There's 6 regions of negative charge. They repel for max separation into an octahedral shape. And then the one slightly different thing that we're going to do this time is we'll say there's 4 bonding regions. 4 bonding, and instead of saying 2 non-bonding, we're going to say 2 lone pairs of electrons. So it is a square planar shape, and that tells us that there. So yeah, that's the difference that we need to do between this year and last year. Instead of saying non-bonding regions, we say lone pairs, and we don't actually need to give the bond angles either, whereas last year we would have had to do that. Okay, then we talk about the polarity. So we would say that, I'll just scroll down a bit and I'll move back up if we need to. So we'll say that it contains polar And then this is a new one, so polar covalence. So we need to be specific about that. Last year we would have just said polar bonds. But then the rest is still the same, like due to the difference in electronegativity, I don't know, change in electronegativity between Xe and F. Yes. So it's just the fact that they're different atoms, so they're going to have different electronegativities. Then we would say that the square pyramid is symmetrical, because the electrons, or the lone pair, are on opposite sides of the molecule, so the charge is spread evenly, and then just dot dot dot, and then so the dipoles cancel. Always going back to the dipoles cancelling. Yeah, have a look at the model answer. In fact, I'll just get that up now. So, kei konei te whakutu tika, here's the correct response. So there are 6 electron clouds in the central atom, 4 bond pairs and 2 lone pairs of electrons. So that's the new part of it. The 6 electron pairs of the central xenon atom are arranged as far apart as possible in an octahedral geometry to minimize repulsion, but due to the 2 lone pairs it has a square planar shape. So this is there is an electronegativity difference between xenon and fluorine. So that's just the same as last year, except that this part of it is new, polar covalent. The molecule is symmetrical due to the position of the 2 lone pairs around xenon being above and below the plane, so the effect of the bond dipoles cancel. So we're still talking about bond dipoles cancelling. And then there is an even spread of charge. Yeah, this is a new one, I guess. I'm not sure how important that would be for the excellence response, but if you can talk about an even spread of charge, I guess that could work. Therefore, yeah, and then a final, it's a non-polar molecule. Yeah, so just practice this as much as you can, find as many questions as you can, and just practicing writing these answers. Thanks very much. I think that's pretty much Lewis diagrams and polarity done. Well done.